what are the biggest kinds of challenges that we face with these kinds of distributed data architectures like data meshes? Are there privacy concerns in that situation, or is it kind of like federated learning where a data mesh actually helps with privacy concerns?
Absolutely. I mean, you touched one of the most important points that a lot of cross-cutting concerns become complex to manage, right? There is an inherent kind of system kind of complexity that comes with distributed systems. When you have a centralized system, a monolithic system, it's very easy. Say, I'm going to put walls around it, and suddenly I've got security and privacy. When you separate, which is actually, I don't agree with that point. I think it makes us feel comfortable, but in reality, it's actually very hard and less secure. And we can talk about privacy and security in a second. But in general, for data mesh to be successful, one of the challenges is the engineering disciplines that have to be put in place so that this autonomous, in data mesh language, we call them data products, these autonomous data products can be secure, can be standardized in terms of their interfaces, can have a level of kind of understanding and trust built into them through the both engineering practices as well as their APIs and interfaces, so that
Mhm.
the application and usage of them doesn't cause a lot of burden on the user, right? The user
Right.
doesn't have to deal with so much diversity. So I think the most challenging part that I don't think we have really built and solved is what the engineering, the operating system that runs data mesh, right? So what are these kind of, how do we automate these cross-cutting concerns, like the um, like the privacy that you mentioned? And that's why data mesh has a fourth component around kind of computational policies, and it expects that every single data product has a set of policies that are being applied to it and maintained by it,
Mm-hmm.
and in an automated fashion.
Right.
So right
So
now,
the
yeah,
data science team can't get access to everybody's pay information across the company from the HR team. So even though they're interconnected, the way like privacy is built into the way that the system is engineered, so that it's not like a free for all and anyone can access any data across the organization.
exactly. Because there are two things that happen. One is the localization of data to a particular domain, and you can then localize and refine, have this fine grain access to different data products. And each of them gets managed differently by the rightful owner, right? By the part of the business that actually, or take aligned business team that is managing that data. So that fine grain kind of data product oriented application of the policies is one way that makes the data more secure. And then the other way, which I don't see much of that implementation, is that once you have this idea of a data product is like a computational data in a way. You've got computation, policy computation, data chain, data transformation computation, as well as the data itself as one unit with clear contracts for sharing it. So once you have this computational data in a way, then the access to the data in future through those computational APIs look very different. So right now, access to data is like, give me all the bits and bytes, and you know, of course, we're building differential privacy and a whole bunch of other techniques, but that, the access of the future is going to be different from just give me the files, give me the rows and columns. Might be actually run this computation that gives me some insight about the distribution of
Ah,
the data on the data,
ah,
and just give me the bits that is relevant and is probably more
right.
secure. So a big shift with data mesh that a lot of people miss is that the reason I didn't use data in the language or data set in the language, and I used the language of a data product, and I had this like quirky name in the book called data quantum, which doesn't catch on, so I'm not going to use it
What
much.
was it? Data quantile?
Yeah, data quantum and data quanta
Oh,
as
data
the,
quantum.
yes, as one, and data quanta as many.
Uh-huh.
But yeah, so data quantum, that it was a language that I used in the book, and it's just too nerdy for people to kind of feel comfortable with it. But the idea was that,
And this is just quickly there for listeners. The book that that Zhamak is referring to is her book. She's the sole author of Data Mesh Delivering Data-Driven Value at Scale, which was published by O'Reilly and came out earlier in 2022. And it is very popular and well reviewed on Amazon as well as O'Reilly.com. So yeah, just a little bit of context.
Thank
So
you,
yeah,
sorry for
a
that.
lot of terms. No, I would have provided a brief intro to the fact that you are an author in the episode intro, but it's nice to dig into it a little bit. And yeah, so in that book, you're not only explaining what data meshes are, but also defining terms in a way, setting the standard in a way for the terminology in the data mesh world. And so some of
Yes,
those you're
that's
saying catch
interesting.
on better than others, and data quantum
Exactly.
hasn't taken off just yet.
It's not taking off, yeah. So data product is basically a node on the mesh, and very quickly got adopted. And there are many manifestations of it, but a certain manifestation of it that I had in mind, which I call data quantum in the book. And yes, it's not very popular. It's kind of scary and from the future, so people don't want to come close to it. It's about the idea that the unit that we will use, this portable unit of exchange of value, data, will have some additional capabilities, and one of those capabilities around actually being able to perform computation on the data. And that really opens up the possibilities of secure data processing that doesn't require direct access to the data itself, and you can kind of push processing up to these nodes.
Super cool. Yeah, I didn't know that at all about data meshes until just now. So hopefully, many listeners out there are also learning that. This is a big. This sounds like a big revolutionary part of the data mesh idea is that you don't need to be pulling out the raw data, a table of data, but actually you're asking for the computation to happen and happen separately from you in the data mesh. I don't know if we can say it like
Yeah.
that.
Yes.
And then it returns for you the result or the insight as opposed to a structured table that then you have to run some model on yourself. That's cool.
Yeah, and I think that there are kind of parallel, and this is a bit futuristic, right? We don't have that. I mean, somebody who's listening, the thing about data mesh is because there is no yet beautifully implemented, like that it came from the future a little bit, right? And we try to build it with our present tools. So people that are listening to this, they will say, if they're coming from data virtualization, federated query engines, they say, well, we have that right now. It's called data virtualization. You run SQL statements distributedly.
Right.
Yes, that's one way of performing computation. SQL is not the only way to perform data computation. Like if data machine learning engineers are training, you know, models, they're not necessarily running SQL, right?
Yeah, they're
So
probably not.
probably very likely not,
Yeah.
exactly. So there are slices of the technology that exist today that can be adapted to this model and take us one step forward, but we still don't have a generalized way of bringing these ideas to life and then allowing different technology providers to kind of stick to it. We don't have a codification of this architecture. So some of the stuff we would talk about today is a little bit more futuristic than what is possible today.